Hi friends, today we will see some practical applications of AutoCAD with AutoLISP. I personally do not believe learning any application command by command, but to see how do we apply those in our day-to-day operations. Here we'll be emphasizing on how do we reduce number of clicks while working with any drawings and gain efficiencies through small automations. You can refer today's session as a general concept and further explore it to your needs. So let's jump into AutoCAD straight away without wasting much time in talking. Frequently use blocks in our drawings. So whenever we want to insert any block, we need to follow a particular process. So let's see how do we insert a block in our drawing. Say for example, I'm giving my command insert. Then I need to browse to the particular folder wherein my blocks are. So a smart way is to drag that particular folder where your libraries are residing in the quick access bar over here, and you can go to your required folder. Say I want to insert a block of a bolt. So I go to fasteners and I take a bolt. So here I have a block of M16 bolt, all three views. Okay, so let me say open it. Then I got to click just OK in order to insert it, and I will just place that block over here. So now I can see I have M16 block bolt inserted over here, but I won't be able to use it as it is, right? Because this is all three views combined together. So I need to explode this, and then I will be able to use it. Say let me check the distance, that this is say 16 mm. Okay, fine. So this is a M16 bolt. So what will happen if I need to insert M8, M10 or M12 bolt? So after inserting this, either I can scale it down or I can create more number of blocks for each and every size. Fair. So let us see a better way to do that. So let me erase this block. Let me purge my drawing. Fine. And let me use one command. Say I want M16 bolt. So I'll give M16 and I'll click a button, and that there it is. So if I measure this bolt size, say it is M16. Now I want M6 or M8. So let me give it M8. So I'll just insert M8 and I will be able to check. Fine. So this is an M8 bolt with all the three views. So now my views are exploded, and I will be able to separately use this bolt in different views I want it. Say I want M12. So I'll click this, and I'm just giving command M12 and I'm getting M12 bolt. If I again go back and measure, so this is M12 bolt. So how did I do that, right? It's as simple. I don't have to go and browse the folder, I insert the block and again scale it down or have more number of blocks in my library. So what does command is doing? So that command is a combination of few things, right? So I'm inserting a bolt, then it asks for the insertion point. So that's where I'm giving a pause command, and then it is asking me to scale the scale of that particular block. So I will go practically in AutoCAD and I'll show you how this sequence I have come to. Okay, so let us go back and say dash insert. So first it is asking me for the name of the block, which I'm giving here as a bolt. Okay, I have given, say I would say, sorry, insert block. Then it is asking me the insertion point. For that I'm doing a pause over here. So I will just click somewhere. Then it is asking me for the scale. So there I've given a scale of 0.625. Sorry. So let us go back. Insert bolt. Let me give some insertion point. Then let me give it some 0.625 as my scale factor. Then Y scale factor is same and the rotation angle is same. So whenever I'm clicking enter in my on my keyboard, I have to I have to put the double quotes over here. So that is how the AutoLISP simply works. It is not at all a rocket science. Anybody can do it. It's as simple as that. So command insert bolt, then pause for the insertion point, then I'm scaling it down. So what I've done here in my library, if I go back to my library, I can show you the bolt. I have only the one bolt, right? So on a countersunk head, hexagon head, and one the bolt. So this bolt is a 16 dia bolt. So what I am doing over here is, let me go back to Lisp, and I'm scaling it down from 16 to 10, and then I'm just ins pressing a couple of enters for Y scale vector and the rotation angle. If I want to change the rotation angle, I can just change the degree over here, and it will get inserted at the required angle. And after inserting, what I'm doing it, I am simply exploding the last object, right? Similar operations we can do for inserting a few structural members. Say for example, I want to insert ISMC 75 by 40, so I can just give say C75 and I'll get it. I want to insert an angle, so I would say A65. So A65 by 6, an equal angle of 65 by 6 thickness. Or if I want to have ISMB 150, so I would say B150. So that's how I'll get it. So it is as quick as that, right? So now let's see what I've done with these commands. Okay, so it is again as simple. So what I've done, I've gone to define function. C75 is my command. Now you are familiar with, right, what I'm talking about, C colon C75. So C75 is my command. It can be anything, right? It can be ABC, XYZ, PQR, whatever you wish that can be there. But just to make it user friendly, I've kept it C75 for ISMC 75 by 40 channel. Then here I'm inserting the channel, I'm giving a pause for insertion point, and I'm giving 3 enters, 1, 2, and 3, because I don't want to scale it this time. So I've just pressed enter for scale, X factor, Y factor, and the rotation angle. So that is what I'm doing over here. And similarly for B150, that is I-beam 150 I can have, or angle 40, 20. So whatever members you have in your library can be added like this, and you can quickly insert those using these short commands. Thank you, and in our next videos we will dive a bit deeper into AutoLISP and see few more commands. Good luck. Thank you.